differential equation, as these are the equation which have derivative operator dy by dx, d square y by dx square, dqy by dx cube, d raised to ny by dx raised to contain in it. Such a equation is called differential equation, as these are some examples of differential equation. As you can observe here, these equations containing derivative operators. Okay, as on right hand side these are expression of variable x and y. If I put right hand side in this expression as any terms, then these are called also equation, but these are algebraic equation, as they are contain only variable x, y and constants. But comparing with these equations, as these are equations in which derivative operators are there are two or more derivative operators in each equation is in here. So we have to understand order of differential equation, as in this differential equation derivative operators in first example as d square by dx square, dy by dx are there. The each derivative operator has an order. As we know, dy by dx is called first order derivative operator, d square by dx square is the second order derivative operator, as d raised to 4y by dx raised to 4 is called fourth order. Seventh order derivative operator will be d raised to 7y by dx raised to 7. In general, nth order of derivative operator can be defined by us. Now, in first example, as d square by dx square is a second order derivative operator, so the highest derivative operator is a d square by dx square. So order of this differential equation is called 2. Okay, now in second example, as you can observe, there are two again derivative operator in which dqy by dx cube has a order 3, so which is the highest derivative operator in this example. So order of this differential equation is a 3. Similarly, in third example, as you can observe here, this differential equation contain only one type of derivative operator dy by dx. So the order of that derivative operator is the order of differential equation. So this is a first order differential equation. And in the last example, as you can observe, there are number of derivative operator in which d raised to 4y by dx raised to 4 is the highest derivative operator having order 4. So this differential equation has order 4. Degree of differential equation is a maximum power as power of highest derivative operator contained in differential equation, which is free of radical sign. This is an important condition which we will see in some examples which we are going to solve. It's called degree of a differential equation. Here degree is a power of highest derivative operator, as you can observe here in first, as d square by dx square is a highest derivative operator in differential equation. So the power of this, as there is given no power, so it is considered as a 1. So the differential equation has a degree, first equation has a 1. Now in second equation, as you observe, dqy by dx cube is a highest derivative operator and power of this highest derivative operator is a 2. So the degree of second differential equation is a 2. Do you understand? Now in a third, as here is given maximum power. As you are going to observe here, dy by dx has two terms in this differential equation, as the first term has a power 2 and second term has a power 1, and dy by dx is the only derivative operator, so highest derivative operator is obviously dy by dx, but maximum power of out of these two terms is a 2. So in this case, degree of this equation is a 2. Okay, and in last example also you can observe, as d raised to 4y dx raised to 4 has a power 1, so degree of last example will be 1. Now if I put here dy by dx raised to 3 in first example, then the derivative operator dy by dx has a maximum power in equation, but this is not highest derivative operator in this equation. So the power of highest derivative operator is only considered, as d square by dx square is the highest derivative operator, as it has a power 1, so degree of this equation is a 1. If this is a power we have given 2, then degree of equation will be 2. Okay, now in this example also, if dy by dx put into power 4, then then also the degree of this equation will be 2. If I change this degree to 1, so then the degree of this equation will be changed. So do you understand what is degree and order of differential equation? Find order and degree of differential equation. As this is a given differential equation, as we have asked the order and degree of this differential equation, as you can observe in example, there are number of derivative operators. Now this is a first derivative operator having order 3, this is a second having order 2, and this is a third having order 1. As third order of derivative operator is the highest derivative operator in this differential equation, so order of this differential equation will be 3. Now the power of highest derivative operator is a degree of this differential equation, as the highest derivative operator dq by dx has a single term and power of that term is a 3, so degree of this term differential equation is a 3. This differential equation contains two derivative operator, but d square by dx square is the highest derivative operator, so order of this differential equation is a 2. Now power of highest derivative operator as d square by dx square has a single term having power 1, so degree of differential equation is a 1. As in definition of degree we come across one word, radical sign. As this is a differential equation, as you observe here, there is a sign root which is in index form converted into 1 by 2, that is fraction. If the index having fraction or negative number, then such a term is called radical sign term. As we have to find degree of differential equation which is free of radical sign, so such a type of examples we cannot find degree directly without simplification. So we make simplification in this example and then find order and degree of this differential equation. For that we take this differential equation which is given here as d square y by dx square is equal to root of 1 plus dy by dx. Now simple algebraic simplification, we can make this equation free of radical sign. As there is a root sign, so we take square of it, the term, then the root sign will be converted into root sign will be eliminated, so we take square on both sides. As this is the equation, on left hand side we get d square y by dx square bracket square, as this is a single term, and on right hand side the root square get cancelled and we get the term 1 plus dy by dx bracket cube. Now you can observe this is the equation which is a free of radical sign, as the power of derivative operator is a positive integer. Now the order of this differential equation is a 2, as highest derivative operator is a d square by dx square, and degree is the power of this derivative operator is a 2. In this example, as there is a fourth root, so we have to take fourth power on both sides. So on left hand side we have d square y by dx square is a single term, the fourth power will be given by raised to 4, and on right hand side the fourth power and fourth root get cancelled and we get the term as y plus dy by dx bracket square. Now we can evaluate order and degree of this differential equation, as order is a 2, as highest order derivative is a d square by dx square, and the power of that term is a 4, so degree is a 4. In this example, as you can observe, radical sign is there, as these all terms are on left hand side. We separate the radical term so that we can simplify this. For that we take these free of radical sign terms on right hand side. So on left hand side we get root of d square y by dx square, and on right hand side as the sign changes we get the first term dy by dx plus xy square. Now as root is there, we have to take only square on both sides. By taking square, the root on left hand side get cancelled and we get the term d square by dx square. As these on right hand side terms are in addition, so we can't take separate square of each term, so we take square of addition, that is dy by dx plus xy square bracket raised to 2. Now this is the equation which is free of radical sign, so we can now define the order and degree of this differential equation, as d square by dx square is the highest order derivative operator, so order of differential equation 2, and the power of that term is a 1, so degree is a 1. In this example, as you can observe, there are two terms which contain radical sign. Now to simplification we make this radical sign in form of index, as first on left hand side we have cube root, so we get the power of d square y by dx square plus 4x as 1 by 3, and on right hand side root, so we take dy by dx minus 1 raised to 1 by 2 as root is there. Now we can observe as these two fractions are there. To make them in integer, we take the common multiplier of both the fraction. As first fraction has a denominator 3, second has a denominator 2, so we get common multiplier 6, and then take sixth power on both sides. As we know, the rule of indices a raised to m has a power, and then a raised to m raised to n is equal to a raised to m into n. That is, we take the power of power, then multiply the indices. So as we take sixth power on both sides, so first term has power 1 by 3 multiplied by 6, so we get d square y by dx square plus 4x raised to 2, as 6 into 1 by 3 is a 2, and on right hand side similarly we have dy by dx minus 1 raised to 3. Now we can define order and degree of this differential equation. As this differential equation contains d square y by dx square, so order is a 2 and degree is also 2, as we can expand this addition, and as we know, for expansion of addition of power 2, the maximum power of term will be 2. So d square y by dx square has a power 2, so degree of this differential equation is a 2. Example, as both terms are in radical sign, on left hand side the cube root, so we take the power as 1 by 3, and on right hand side fourth root, so we take the power as 1 by 4. As these two fraction has a common multiplier 12, so we take 12th power on both sides. On left hand side, by multiplying indices with 12, we get dy by dx plus y raised to 4, and on right hand side we get d square y by dx square, as 1 by 4 into 12 is a 3. Now we can define order and degree of this differential equation, as the d square y by dx is the highest derivative operator, so order of it is a 2, so equation has the order 2, and degree, the power of this term is a 3, so degree is equal to 3. In this example, as we have given the expression which contain derivative operators, as you observe, this d square over dx square is in denominator. As we know, the term in denominator has an index negative as we take it in numerator. So we have to make first simplification by taking this term on left hand side, so that it came into numerator. As on left hand side y is there, so we get y into d square y by dx square is equal to, on right hand side we get 1 plus dy by dx bracket square raised to 3 by 2. So first simplification we make taking it term in denominator to numerator by transferring it on left hand side. Now as we observe, here is a fraction of index 3 by 2 of this operator, so we have to make it as a integer, so we multiply this as a 2. That means we take its square. By taking square on both sides, we get on left hand side, as there is a product, so we take separate square of each term. So first term y square we get, and second term d square y by dx square bracket square. On right hand side, as this term has index 3 by 2, taking square by multiplying by 2, the power 2 to get cancelled, we get term 1 plus dy by dx bracket square raised to 3. Now we can define the order and degree of this differential equation, as the order is a 2 and degree is also 2. Similar exam we are asked, as here the term of denominator is given in numerator directly, so we can only take square on both sides. The term will be 1 plus dy by dx bracket square raised to 3, as 3 into 2, 3 by 2 into 2, 2 to get cancelled, and on right side we take square of each term separate, so k square plus d square y by dx square bracket square. Now you can define order is a 2 and degree is also 2. In this example also you can observe this, the operator term is in denominator, so we have to take it as numerator or simplifying this, as we can here making simplification by multiplying this expression, whole expression by dy by dx. So on left hand side, multiplying by dy by dx square by dy by dx, we get dy by dx raised to 3. On right hand side, as addition is there, so we multiply first term, we get 1, as denominator get cancelled with dy by dx, and in second term we get 2 into dy by dx. Now we can define order and degree of this differential equation. As we observe, dy by dx is a single operator contained in differential equation, so order of it is 1, so equation has order 1. Now as it has two terms with power 3 and 1, the maximum power is a 3, so degree of this differential equation is a 3.